So in this video, we're going to talk about how to factor trinomials where a is not 1. So here we have standard form of a quadratic, remember, which is ax squared plus bx plus c. So a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant term. So when we factor a trinomial, we're going to be figuring out the expressions that can be multiplied together to form the original trinomial. So for example, the factors of 2x squared plus 7x plus 3 are x plus 3 and 2x plus 1. So that means that if I multiply x plus 3 times 2x plus 1, I get the original trinomial, which is 2x squared plus 7x plus 3. So when we find factor pairs, remember we do that a little bit differently for trinomials where a is not equal to 1. What we have to do first is figure out what two numbers will multiply to a times c, okay? So we're looking for numbers that will multiply to this product. And we also need the factor pair that's going to add to b. So for example, if we were factoring the trinomial 2x squared plus 7x plus 3, we would look for what two numbers will multiply to 2 times 3, which is 6, and add up to 7. So that's going to give us the pair 1 times 6 because that equals 6 and 1 plus 6 equals 7. So remember also when we're factoring when a is not equal to 1, we can't just write the factor pair in our final factored form. We have to do a few extra steps before that. So factoring, remember, is the opposite of multiplication. So remember when we were multiplying binomials, I told you that, you could take this binomial and distribute its terms to the second binomial. So we got x times 2x plus 1 plus 3 times 2x plus 1. Well, today we're going to be going backwards from this. So you're going to be seeing something like this, and then I'm going to tell you to factor out the common binomial of 2x plus 1 and go back to this form, x plus 3 times 2x plus 1. So remember, an important step in any factoring problem is to figure out the signs of the factors. So we're going to be looking at the signs of AC and the sign of B to determine this. So if AC is positive, both our factors will have the same sign. So we'll have 2 positive or 2 negative. If B is positive, we'll have the 2 positive numbers. If B is negative, we'll have the 2 negative numbers. If AC is negative, our factors will have the opposite sign. Remember, the reason for that is because the only way to get a negative number is if you multiply a positive and a negative number. If B is positive, that means the bigger factor in the pair will be positive. If B is negative, that means the bigger factor in the pair will be negative. So here are the steps to when we factor when a is not 1. You're going to first make sure that your trinomial is in standard form, and then factor out a GCF if you can. Then we'll determine the factors of AC, and based on the sign of B, we're going to adjust the signs of the factors. Then we'll determine the factor pair that adds to B. The next steps now are going to be factoring by grouping. We're going to use the factor pair as the coefficients of x, and put the terms of the expanded polynomial into 2 groups. We'll factor out the GCF of each group and then finally factor out the common binomial to write the product of the inside terms times the outside terms. Remember to include the GCF if you factored one out in step 2. So since we're going to be using factoring by grouping a lot today, I just wanted to remind you of how that works. So remember, first we look at a times c, which in this case is 30, and we need to figure out the factors of 30 that are going to add up to 13. So in this case, that's going to be 3 and 10. So we use that to expand out that x term. So we have 2x squared plus 3x plus 10x plus 15, which we then put the terms into 2 groups. And then we find the GCF of each group. So from the first group, I can factor out an x. So that gives me x times 2x plus 3. From the second group, I factor out a 5, which gives me 5 times 2x plus 3. So notice now I have this common binomial, that 2x plus 3, so I go ahead and factor it out, and then I write the terms that are on the outside, so that x plus 5. Okay, so that's how you factor by grouping. So let's look at this example. So this is in standard form, so I'm going to go ahead and label A, B, and C. So A times C in this case is going to be negative 30. So I need factors of negative 30 that are going to add up to 13. So let's list out the factors of 30. They're 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So 30 is negative, so I need a positive factor and a negative factor. And since B is positive, I'm going to make my bigger factor positive. So I'm going to make all these smaller factors negative, and now let's look at the sums. Negative 1 plus 30 is 29. Negative 2 plus 15 is 13. And so that's the correct combination, but you can check the other ones just to make sure. So now I'm going to use that to expand out that x term. So I have 6x squared minus 2x plus 15x minus 5. I'm going to put the terms into two groups. So I have 6x squared minus 2x and then plus 15x minus 5. And so now let's look at the first group. So notice that I have a GCF of 2x that I can factor out. So I have 6x squared divided by 2x minus 2x divided by 2x. And so that gives me 2x times 6 over 2 is 3, x squared over x is x, minus 2x over 2x is 1. Now let's look at the second group, the 15x minus 5. So I can factor out a 5, so that gives me 15x over 5 minus 5 over 5. So we have plus 5 times 15 over 5 is 3, and then I have x, minus 5 over 5 is 1. So now notice I have that common binomial. I have that 3x minus 1. So let's go ahead and factor that out. And then I'm going to write the outside terms, which are 2x plus 5. So that's going to give us the final factored form, 3x minus 1 times 2x plus 5. So I want to point out an important distinction that sometimes can be confusing when we're working on factoring. Factoring when a is 1 is very different from factoring when a is not 1. Notice that we need a lot more steps when you're factoring when a is not 1. Because when we factor when a is 1, all we need to look at is the value of c and then figure out the factors of c that are going to add up to b. Right? So in this case, we get 3 and 5. And then once we figure out that factor pair, we just go ahead and write our factors based on that. Well, factoring when a is not 1 is very different because one important difference that we see here is that we have to find AC, right? So we're going to multiply a times c together and then look for the factors. We're not just looking at the value of c. Another important difference is that once you find the correct factor pair, you don't just use it to write your factors, okay? And that's a mistake I see a lot of. When we're factoring when a is not 1, we actually have to go ahead and expand that x term and then use factoring by grouping to figure out the final factored form. So just important to keep this in mind when you're working on these problems because the steps are going to be very different. So let's continue and let's practice with 3x squared minus 8x plus 4. So this is in standard form, so I'm going to identify a, b, and c. So if I go ahead and do a times c, that's going to give me 12. So now I need to figure out two factors of 12 that are going to add up to negative 8. So let's write out those factors. We have 1 and 12, 2 and 6, and 3 and 4. So now let's think about the signs. So AC is positive, so we have two negative or two positive factors. Since B is negative, we have two negative factors. So let's go ahead and make all of these factors negative. So when we add those up, the first pair gives us negative 13. The second pair is negative 8, and the third pair is negative 7. So this is the correct combination. So we have now 3x squared minus 2x minus 6x plus 4. So let's put these terms into two pairs. So we have 3x squared minus 2x, and then plus negative 6x plus 4. So let's find the GCF of the first set. So the first GCF is going to be x, so I'm going to go ahead and divide an x out of both terms. And when I do that, that gives me x times 3x minus 2. So now let's go to the second set, and if we look at negative 6x plus 4, notice that these have a common factor of 2, but when I factor out that 2, I'm going to go ahead and factor out a negative along with it, and that's something that you want to do every time that first term is negative. So go ahead and factor that out as a negative 2, and so I have negative 6x over negative 2 plus 4 over negative 2. So that plus negative 2, I'm going to turn that into a minus. So I have minus 2 times negative 6 over negative 2 is 3. And then I have x. And then plus 4 over negative 2 is minus 2. So now we can factor out that common binomial, that 3x minus 2. And then we have the outside terms, which are x minus 2. So that's the factored form of this expression. So now you can go ahead and pause the video and try doing this example on your own. So in this example, when we do a times c, we get negative 14. The two factors of negative 14 that will add up to 5 are negative 2 and 7. So we can expand out our polynomial. The first set, when we factor it, we get 2x times x minus 1. When we factor the second pair, we get 7 times x minus 1. So we can factor out that common x minus 1 and then write 2x plus 7, right, our outside terms. So remember, when you're factoring trinomials, first make sure that the trinomial is in standard form ax squared plus bx plus c. Based on the values of b and a times c, you can expand the x term of the trinomial. You can then use factoring by grouping to determine the factored form of the original trinomial.